in looking at this top problem, we have, the, just like the last diagram I showed, you have these two triangles formed. One side is parallel to another. So when you look at these, you could also identify they share this common angle, and then these pair of corresponding angles are equal. Okay, so by AA similarity, we know enough that these two triangles are similar to each other. Okay, so two things I would always do. I would always rewrite any figures that are overlapping or any figures that aren't oriented in the same corresponding direction. So here we have two overlapping shapes. What I would do is I would redraw them individually, label them properly. So this side was 20, this side was 3, this side here was 4, and this side here is this whole distance x and a plus 4. So if you separate them and redraw them individually, it's often easier to see what pieces need to line up in order to solve. Okay, and now we're going to solve for proportions here. I would always encourage you start with the variable on top. So take the expression with your unknown, x plus 4. That corresponds to what side in the smaller triangle? 4. And then set it equal to the known ratio. The known ratio is 20 over 3. And so then it's just a matter of solving your equation. Okay, so here if you multiply both sides by 4 to get rid of your fraction, x plus 4 is equal to 80 thirds. Subtract a 4 from both sides. Subtracting a 4 is equivalent to subtracting how many thirds? 12. So if we think of that, we get our value x to be 68 thirds. Okay. So we set up, find our similar triangles, and work to solve the proportion. All right, let's try this second example here. Again, I'll talk through it. So here the 1 tick mark means 8, so I can label this other side with 1 tick mark as 8. The 2 tick marks represent 20. Label that other side 20. So what we have right here is we have these two triangles. They're both isosceles triangles and they share this vertical angle pair. So you know that you have two sides that are proportional, a ratio of 20 to 8 and 20 to 8. And then the included angles are equal. So by SAS, similarity, you know that these two triangles are going to be similar to one another. Okay, so what you can do here is you can simply start with your variable. Y is to the side opposite the one angle with 1 tick mark, so 7, as the other sides are to each other. So the other known side from the triangle from which y comes is 20, and that corresponds to a side of 8. And so it's just a matter of solving once again. So 4 goes into 20 5 times, 4 goes into 8 twice. Multiply by 7 to get rid of your fraction. You get y is equal to 35 halves. Okay. All right, I want you to try this last one on your own. This is supposed to be similar to. Okay, so in this figure, KJL and NMO are similar triangles. See if you can find the unknown measure MN, please. Okay. Are these oriented in the right direction? Do they correspond the way that they're drawn? KJL, so K corresponds to N. So they're not drawn in the same orientation. So my suggestion would be redraw your figures so that they are to the same orientation. So here's JKL. So K corresponds with N, so that goes on top. M corresponds with J, so that goes to the bottom left. And O corresponds with L, so that goes to the bottom right. If you do that and then label your pieces, so JK is 7, KL is 8, MO is 11, and NO is 10. It's now easier to solve it visually because you can set up your proportion. Take your unknown, here's your unknown, MN, and it corresponds with 7. Okay. And then that's equal to, oops, so this is the right way. I think I told you guys the wrong one. So that's equal to the known ratio. So when you look here, the only sides that we have measures for the corresponding pieces are NO and KL. So we need to set it up as 10 over 8. Okay. And so the final step, to multiply both sides by 7. And if you simplify, 2 goes into 10 5 times, 2 goes into 8 4 times, and you get mn is equal to 35 fourths. And that would be your solution.